Okay, class 9s, welcome back after a long time. Now we have two more chapters to go through, pressure and fluids, and the next chapter is based on Archimedes principles and all that. Let's finish it off. Two more chapters. Now, the first one that we have is thrust and pressure. Now, what is thrust and what is pressure? Thrust, they say, a force can be applied on a surface in any direction, mind you. Thrust is a type of force, but thrust is a special type of force. It's not any force. Okay? Now, force can be applied on a surface in any direction, but if the force is applied in a direction normal. Now, this normal is the normal from your your light. Remember, okay? The perpendicular, the normal that we have in the case of your light. So this normal is that light which is perpendicular to the surface. This normal is not normal, abnormal. No, it's not that. Okay, so when the force is applied normally, as they say, on a surface, normally means the normal that we have it at 90 degree to the surface, that force is called thrust. Not any force, because force can be applied in many directions. As you have it, we have done force before, so that is thrust. But as far as the unit is concerned, it's the same as force. Okay, Newton, dyne, whatever you say. Okay, so thrust exerted by a body placed on a surface is equal to its weight. Okay, so thrust is something which is directly proportional to its weight. We know that thrust is force. Force is mass into acceleration. Okay, F is equal to ma, as we say. Okay, so thrust is a type of force. For the force is something which is directly related to the weight. So thrust is same in whatsoever position of a body, okay, placed on the surface. Thus, the thrust exerted by a body on a surface is directly proportional to its weight, as they say. But as now again, since thrust is a force, so it's a vector quantity. So these are all actually same thing, but given a different form here. Unit of thrust. Okay, it is measured in the unit of force. The SI unit of thrust is Newton. Okay, and 1 Newton is equal to 10 to the power 5 dyne, and so on. The gravitational unit of thrust, we have done that, is 1 kgf, which is equal to 9.8 Newton, or 1 gf is equal to 980 dyne. These are all same thing. Only difference is now we are treating thrust in as a very special type of force. Then they have given some examples there. No, sorry, what's pressure? Pressure is the pressure of a thrust depends on the area of the surface on which it acts. That is, the effect of thrust is less on a larger area, thrust being constant, okay, while it is more on a small area. Okay, so if your thrust is more, area is less, the pressure will be more. So pressure is something which is inversely proportional to the area. The same thrust, we'll be talking about it in terms of mathematics. We'll see to that, don't worry. Okay, the same thrust can produce different type of pressures depending on the area on which it is standing. The same thrust can produce different type of pressures depending on the area on which it is standing on the surface. Okay, if you stand on a loose sand, your feet sinks into the sand. But if you lie down on the sand, now when you're standing, your weight is fixed. Your weight is fixed. So if you are standing on the sand, okay, with your feet, on your feet, okay, the area is less, so you have a tendency of sinking in the sand. But if you lie down, okay, your weight remains same, your weight doesn't change, but since you're lying down on a larger surface area, so the thrust will be less. Okay, I mean, not the thrust is less, the pressure will be less. Since the area is more, the pressure is less. The same thrust, because your weight does not change. Now they are giving you small examples. We'll be talking more and more of examples of this. Okay, so what is pressure? Pressure is the thrust per unit area of a surface. Okay, so what is the expression for pressure? Pressure is thrust by area, which is force by area. So pressure is a scalar quantity. Okay, so what is the unit of pressure? Unit of pressure is thrust by area. Okay, now thrust is Newton. Area, if I take it in SI unit, thrust is Newton, area is meter square. So it becomes Newton meter to the power minus 2 Newton per meter square, which is taken as Pascal. Okay, 1 unit, we say Newton per meter square, thrust is Newton per meter square, but when we talk as a single unit, we say pressure is Pascal. So what is 1 Pascal? 1 Pascal is when 1 Newton force is acting on an area of 1 meter square. 1 Pascal is the pressure exerted on a surface of 1 meter square by a force of 1 Newton. Now if you put it in your own words, it is when a force of 1 Newton is acting on an area of 1 meter square. That's 1 Pascal. Okay. Now if you take it, if it is measured in kgf, then it will be kgf meter to the power minus 1. CGS unit is dyne per centimeter square. Dyne per centimeter square is equal to that. Therefore it is 10 dyne per centimeter square, and so on. Is that okay? If pressure is measured in GF and area in centimeter square, then the unit of pressure, now these units are very important. Okay, the unit will be GF per centimeter square. These are just interrelated units. Okay, units which are interrelated. Then we have other units of pressure. 1 bar, which is, now these are bigger pressures. Okay, bigger units. 1 bar is 10 to the power 5 Newton that. 1 millibar is 10 to the power that, and so on. The atmospheric pressure is generally expressed in terms of height of mercury. Now this we'll be talking about it in the next chapter also. Okay, so let us not go very deep into this. For the time being, you just let it be. We'll be talking about atmospheric pressure later on. Okay, later on in the chapter, and we'll be discussing more about it. How is it related to mercury pressure? Okay, so just for the time being, just know that the atmospheric pressure is expressed in terms of height of mercury, which is 76 centimeter of mercury, or 760 mm of mercury. Is it okay? Just hold on with this part. We'll be talking about it later. Is it okay? There are other atmospheric pressure units. 1 torr. 1 torr is 1 mm Hg, and 1 atmospheric pressure is so many torr. Okay, just remember these relations. Okay, so what are the factors affecting pressure? Pressure exerted on a surface depends on 2 factors. Okay, as you know, pressure depends on 2 factors, that is area and mass. The area and the thrust. Sorry, not the mass. Okay, the area and thrust, because pressure is force per unit area. So pressure will be dependent on force and area. Directly related to force, inversely related to area. Is it okay? Now look at this fact. Look at this. They are just trying to explain thrust and pressure with a diagram over here. Okay, it's a very nice explanation. Look at this block here. The thrust is 4 kgf. The weight of the block, or the thrust, you know that the thrust comes from the weight. So the thrust is 4 kgf. Now that's your block over there, 20 by 10 by 5. Now look at the way it is standing. Look at the way it is standing. So it is standing on an area of 10 by 5. This is 10 by 5. Is that okay? So what is the pressure? Pressure is force by area. So 10 by 5, 5 into 10 is 50. Now they are doing it in centimeter square. They are leaving it as it is. Okay, so it works out to 0.08 kgf by centimeter square. But though that is not the right expression of pressure, but they are leaving it just to show you the difference and all that. So you can leave it as it is for the time being. Okay, look at this one. The same block now resting over here. It is resting on an area of 10 by 20. This is 10 and this is 20. It is resting on an area of 10 by 20. Thrust being same. So pressure is thrust by area. Work it out, it comes to 0.2. So the same block, when resting on different surfaces, are producing different type of pressure. Is it okay? Clear? Right? Now that's the calculation that they are doing over here. Obviously, larger the area, where is this now? Yeah. Obviously, larger the area on which a given thrust acts, lesser is the pressure exerted. Larger the area, because pressure is inversely proportional. Just remember, pressure is inversely proportional to area. Okay, that's figure 1, and then figure 2, and so on. Okay, so what are the ways of increasing pressure? What are the ways? If the thrust is constant, what are the ways in which you can increase pressure? What is the way? Okay, so if thrust is constant, if I decrease the area, the pressure will increase. Right? Now for a given thrust, the pressure on the surface is increased by reducing the area. It's the same thing that they keep on talking again and again. Okay, because pressure is inversely proportional to area. Okay, now they are giving two simple examples over here: the end of a nail and a pin, and made pointed, so that when you have a nail, okay, you don't use a blunt nail, we use a pointed nail. Okay, now this is a very pointed tip here, right? That's a very pointed tip, you can say. Now if I have used that as a nail, okay, and I apply pressure here on this part here, okay, the lesser the area, the more will be the pressure. Cutting tools, your knives and all are very sharp. If they are sharp, they cut easily. Why? Because the area is less, the pressure related to it will be more. Way of decreasing the pressure. How do I decrease the pressure? By increasing the area. Thrust being constant. If I keep the thrust constant, how do I decrease the area? How do I decrease the pressure? Pressure can be decreased by increasing the area. Okay, then they have given two small examples over there. We stop here, we go to the second part.